In this video we're going to look at functions and their graphs. So the first thing that I want to look at is how to find the domain of a function. So in the first function I have f of x is equal to the square root of x plus 3. And remember, underneath the square root can't be negative. So we want to set the inside greater than or equal to 0. So I'm going to say x plus 3 has to be greater than or equal to 0. And then solve for x. So x has to be greater than or equal to negative 3. So now my domain is bracket, because we can include negative 3, so we use a bracket, to infinity. In this next example I have f of x is equal to 3 divided by x minus 7 times x plus 3. And in this function, remember the denominator cannot equal 0. So our denominator equals 0 when x is 7 or x is negative 3. So we know that x cannot be 7, and we know that x cannot equal negative 3. So our domain is going to be negative infinity to negative 3 union negative 3 to 7 union 7 to infinity. In this next example, I have the square root of x minus 3 divided by x minus 9. So now we have two places where we have to be careful. We can't have a negative number underneath the square root, and also we have a denominator that can't equal 0. So here I have x minus 3 has to be greater than or equal to 0, and also that x cannot equal 9. So now I'll solve our inequality. So x has to be greater than or equal to 3, and then we cannot equal 9. So our domain is going to be 3, and we're going to use a bracket because we can include it, to 9 union 9 to infinity. In this next set of functions, I want to graph them and state the domain and range. So what I like to do is find the domain first. So we'll say domain. That way you don't graph a place that doesn't exist. And we know that x minus 2 has to be greater than or equal to 0. So x minus 2 greater than or equal to 0. And x is greater than or equal to 2. So our domain is 2 to infinity. So we don't want to graph anything smaller than 2. And then to graph it, we can make ourselves a t-chart. So I'll give myself some points so I can graph this function. And whenever I have a square root, I like to find numbers that are perfect squares to make it a little easier. So the first point I'm going to graph is the endpoint, 2. And when we put 2 into our function, we have 2 minus 2 is 0, and the square root of 0 is equal to 0. And the next point I'm going to pick is 3. 3 minus 2 is 1, and the square root of 1 is 1. And the last point I'm going to graph is 6. 6 minus 2 is 4, and the square root of 4 is equal to 2. So I know that these 3 points are on my graph. So I'm going to graph 2, 0. And remember, 2 is included, so it's a solid dot. And then 3, 1 is a spot on the graph. So we have a dot here. And then 6, 2. 4, 5, 6, 2. And then we can draw our function. And now we want to look at the range. So we can see that there are no negative numbers in our range. So range, and 0 is included in this function. So we're going to say our range is 0, and the bracket to show that we're including 0. And then this function continues to the right and up forever, so it's infinity for the range. Remember, range shows the y values that can be obtained by the function. In my next example, I have a piecewise function, and we can see that f of x is equal to 1 minus x if x is less than 0, and x squared if x is greater than 0. But if you notice that both of them, one of them says less than 0 and one of them says greater than 0, so our domain does not include 0. So domain is negative infinity to 0, union 0 to infinity. And now we'll graph each piece. So 1 minus x if x is less than 0. So I'm always going to graph the endpoint, or where the function splits here. So I'm going to look at 0. And if I plug 0 into 1 minus x, I get 1. So 0, 1. And we're going to have an open circle because the function does not exist there. And then because this is a linear line, I'm just going to plot one other point. So we'll go over a couple units, so to negative 3. And if we put negative 3 into 1 minus x, we get 1 minus a negative 3, or 1 plus 3, which is 4. 2, 3, 4. So negative 3, 4 is a point on this function. And now I'm going to draw a straight line from these 2 points. So we'll have a line that goes from our open circle through our dot and then continues forever. And now, so x squared is quadratic, and again I'm going to start off by putting 0 in, and here we'll go ahead and make a chart again to make sure that everyone sees it. So 0, if we put 0 into x squared, we get 0. And if we put 1 in, we get 1. And 2, we get 4. So I'm going to graph these 3 points. And remember, 0 doesn't exist, so it's an open circle. And then 1, 1 is a point on the graph. And 2, 4 is a point on the graph. And now I can draw a line through those points. So this is what our function looks like. Now if we look at the domain, again we don't have any negative numbers, but this time 0 is not included. So we have to make sure that when we write the range that we have not included 0. So we're going to use parentheses at 0, and then our range goes to infinity. And that's how we find domain of functions and how we graph functions.